Simplest mental model. Think of it like this. Thing, capacitor, what it is, tiny electrical storage, bit, stored 0 or 1, register, tiny fast storage inside CPU, instruction, CPU command, micro-op or U-op, smaller internal CPU action, buffer, waiting line for micro-ops, execution unit, worker executing micro-ops. So micro-ops are not electricity. They are tiny actions the CPU schedules internally, while the electricity or transistor capacitor underneath physically make it possible. So the transformation is the capacitor, electricity, and the transistor, while these micro-ops are really just a transformation concept. It's a way for us to define, for humans to understand how those transformation actually works. So, so, hmm. So I don't understand. For example, this is your question: how capacitor relates to discharge in monitor? So how the capacitor relates to discharging the monitor? So what you're asking is actually the foundation beneath computers. So like how does the capacitor change the monitor of our screen? How the electricity actually change the LCD? So these are the foundation of computers, CPUs, monitors, internet, Wi-Fi, phones, electricity, even modern business and money. And the reason it feels confusing is because the book is climbing through many layers at once. So you have universe physics, then waves, then electricity. So the physics in the universe and the waves that uh, encompassing that energy. So the electricity actually came from wave and frequency, and then the combination of electricity and electromagnetism. Electricity and waves produce electromagnetism. So these are technologies. So this is how we combine things to produce or to execute functionality even the days before humans, such as combining, I forgot what it is. I think it's for combining some tool for creating a house, like a lever, etc. So we have four technology tools in history that allow us to create a house. So that's how magnificent technology is, because we were able to combine these concepts, this physics, to create a better combination. So electromagnetism, materials like silicon, transistors, memory. So after magnetism, we have silicon, and we create that as a transistor or switch. Then we put that into a memory. So a memory is just composed of many switches. And then CPU as well is just a many switches, then software, then apps, then businesses. The important thing is you do not need a physics PhD. You only need the 20% that explains 80% of computing. That is exactly the correct mindset for business and execution. So the real foundation of computers, forget the advanced math first. Everything reduces to this: energy that humans learn to control. That's it. Electricity is controlled energy. Computers are systems for controlling energy extremely precisely. First, the most important idea: flow. Electricity is basically movement of electrons, like water flowing through pipes. This analogy explains most beginner electronics. So water system, you have water. Electrical system, you have electrons. Water system, you have pipe. Electrical system, you have wire. Water system, you have water pressure. Electrical system, you have voltage. Water system, you have water amount flowing. Electrical system, you have current and amperage. Water system, you have narrow pipe. Electrical system, you have resistance. So this is the 80 or 20 foundation. So the resistance is the pipe, because the the pipe determines how the pressure would undergo, because some blocks could be pushed by a big pressure, just like with some blocks in electricity could be pushed by a big voltage. Second, why capacitors matter. A capacitor is basically temporary energy storage, like a tiny rechargeable bucket. The books explain this here. So the capacitor stores electrical charge, then releases it later. That is called discharge. Third, why monitor capacitors are dangerous. All CRT monitors had very large capacitors. Why? Because the monitor needed large bursts of energy to control electrons beams. So the old monitor actually needed a large capacitor to control that electron or the water in the pipe. Even after unplugging the monitor, capacitor still contains stored energy. So that electron or the water waiting through that waiting in that water pressure are still there even if the monitor are turned off. So stored electricity, sudden discharge into human. So if you have stored electricity or electrons, sudden discharge to human is a dangerous shock. That's why repair people fear CRT monitors. This connects directly to the RAM chapter. RAM capacitor, store tiny charge equals to bit 1, same principle, different scale. So we also store those electrons in RAM. It's just a lower electron percentage. So how CPU step down electricity? Your CPU cannot handle wall electricity directly. Wall outlets such as 220 volt Philippines, CPU 1 volt to 1.4 volt. So a CPU of very low, like 200 less times than we have in our outlet. So the computer power supply takes a huge dangerous voltage, reduces it, stabilizes it, feed tiny safe voltages. This is called step-down transformation. The book explains transformation here. Now, what transformer really is? A transformer is basically controlled magnetic energy transfer. So you are controlling the magnet electron, because again, an electricity produce a magnet around it, or electromagnetism. So you're controlling that transfer of that energy, and then you're lowering it. So electricity create magnetic fields, then magnetic fields create electricity. So again, they are looping each other. So the book explained that here. So electricity and magnetism, this relationship powers civilization, literally. So why waves matter? The universe transfer energy through waves. Example, thing, sound, wave type, air pressure waves. So thing, light, wave type, electromagnetic waves. So a light is just an electromagnetic wave or magnetism we discuss. And then Wi-Fi is just a radio waves. So that's a different kind of waves. So this Wi-Fi, this light, this sound, or what thing that powers humans, Bluetooth, 5G. Bluetooth and 5G is also radio waves. Microwave is electromagnetic waves as well, as same as light. So this light are powering the civilization. So your Wi-Fi is literally invisible energy, waves carrying information. So your light at home is also invisible energy that creating that is carrying information, kind of like a memory. So this explain this in chapter 1.7. What frequency means? Frequency simply means how fast something repeats. Example, as the wave, and then high frequency. So more frequency, more cycles per second. So the more you cycle per second, of course, the more frequent it is. It's measured in hertz. So examples, frequency 1 hertz meaning once per second. Frequency 1000 hertz meaning 1000 times per second. Frequency 1 gigahertz meaning 1 billion times per second. So your CPU is 3.5 gigahertz. That is why it's fast. It can execute a lot in a small time. Means roughly 3.5 billion clock cycles per second. So why clock speed matters? CPU has an internal rhythm like a heartbeat. Like tick, 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 tick. Each tick allows operation. Higher frequency, more operation per second. So the clock speed or the internal rhythm of the CPU is what determines its speed, and that is determined by its frequency. So the higher the frequency it can do per second, like that billion, the more operation it can perform. So that's why gigahertz became famous. How silicon handles electricity. This is the most important semiconductor idea. Silicon is special because it can sometimes conduct electricity and sometimes block it. That is the miracle. The book explains it here. That's what allows human to build electrical switches called transistors.